The following is an encore presentation of Everything Everywhere Daily. In 1961, at the Green Bank Observatory in West Virginia, a small conference was held for astrophysicists. The meeting was organized by Cornell University professor and astronomer Frank Drake. The subject of the conference was the search for extraterrestrial life. In preparation for the conference, he jotted down his thoughts in the form of an equation that has changed how we think about life on other worlds. Learn more about the Drake equation and the variables which make it up on this episode of Everything Everywhere Daily. This episode is sponsored by ButcherBox. As we gear up for the 4th of July, there's one thing on everybody's mind: barbecues and cookouts. And what's the secret to an unforgettable cookout? High-quality meat, of course. And that's where ButcherBox comes in. ButcherBox delivers 100% grass-fed beef, free-range organic chicken, heritage breed pork, and wild-caught seafood right to your doorstep. No more last-minute runs to the store or settling for subpar cuts. With ButcherBox, you get the very best every time. Plus, all their products are humanely raised with no antibiotics or added hormones. It's quality you can taste and feel good about. Celebrate Independence Day by going to butcherbox.com/daily and use code DAILY60 at checkout to enjoy your choice of bone-in chicken thighs, top sirloins, or salmon in every box for an entire year. Plus, use code DAILY60 to get an additional $20 off your first 3 orders. Again, that's butcherbox.com/daily and use code DAILY60.
Well, we got a minute. I'm going to buy that truck I've been wanting.
Wait, don't you need weeks to shop for a car?
I don't. Carvana makes it super convenient to find exactly what I want.
Hold up. You're buying a car on your phone? Isn't that more of a laptop thing?
You can shop wherever you want.
I like to do my research, read reviews, compare models. Plus, Carvana has thousands of options. How'd you decide on that truck?
Because I like it.
Oh, that is a great reason.
Go to Carvana.com to sell your car the convenient way.
In the late 1950s and early 1960s, the science of astronomy was making huge strides. In particular, the field of radio astronomy had been taking off, and many new discoveries were being made. With these new discoveries and new observation tools, the questions of extraterrestrial intelligence began to come to the forefront, and were taken more seriously by scientists. It was noted that the radio telescopes of the late 50s were sensitive enough to pick up radio waves that might have been broadcast from other civilizations. It was in this environment that Frank Drake created the Drake equation. The Drake equation is nothing more than an attempt to try to identify the factors which determine the number of civilizations we could potentially communicate with in our galaxy. The Drake equation is really nothing more than an educated guess, and there have been criticisms of the equation and suggestions that it needs to be updated in light of discoveries over the last 60 years. Nonetheless, with that, let's get into the equation itself. The entire equation, when read out, would read n equals r star times f sub p times n sub e times f sub l times f sub I times f sub c times l. If that sounds really complicated, it really isn't. It's just using a lot of math language, and each of the variables can be explained in a very easy to understand way. So let's start with n, which is the entire point of the equation. N is just the number of civilizations in our galaxy that we could communicate with. That's what we're trying to figure out. The other 7 variables are all things that would determine the number of civilizations. Many of the early attempts to assign values to these variables were really nothing more than an educated guess. Since 1961, we have gotten a far better idea as to the numbers for a few of these values. R star is the first variable. It represents the rate of star formation in the Milky Way, or how many new stars are created every year. Drake's initial guess in 1961, and it was just a guess, was that there was about 1 new star that formed every year in our galaxy. He assumed that this was a conservative estimate, and he was right. The Milky Way has somewhere between 100 to 400 billion stars, and the current estimate is that approximately 3 solar masses of stars are being created each year. That could be 3 stars like our Sun, or 1 big star 3 times the size of our Sun, or 5 stars that are smaller than the Sun. Here I should note that the Drake equation is only designed for our galaxy. If you wanted to calculate this for the entire universe, you'd have to multiply everything by the estimated number of galaxies in the universe, which is somewhere between 200 billion and 2 trillion. The second variable is F sub p, which represents the fraction of stars that have planets. Of all the variables in this equation, this is the one where the most progress has been made in the last 60 years. In 1961, no one even knew if other stars had planets, or if they did, how common of an occurrence it was. Since then, we have discovered thousands of planets around other stars. In fact, we found so many that it's assumed now that pretty much all stars have planets, and that it's a natural part of the formation of stars. That would make the value of this variable 1 or very close to 1, and it really almost renders it irrelevant. In many of the updated versions of the equation, this variable is now eliminated entirely. In Drake's original 1961 estimate, he put this value at 0.2 to 0.5, which, as it turns out, was a very conservative estimate. The third value is n sub e, which represents the number of planets per solar system that can support life. Here we have made very little progress because the tools and techniques we have to detect planets can only detect very large planets, which have a measurable effect on the star which it orbits. Our estimates of this number should improve over the next several decades as new telescopes will be built and new techniques developed which will allow us to find smaller planets. The key thing which astronomers will be looking for are planets inside the habitable zone of a star, also known as the Goldilocks zone. It's the zone that isn't too close to the star, like Venus, nor too far away, like Mars. The 2013 Kepler mission concluded that there could be 40 billion Earth-sized planets within the habitable zones of stars, which would give this variable a value of 0.4, assuming that there are 100 billion stars in the galaxy. Drake initially guessed that this value would be between 1 and 5. The fourth variable is F sub L, which represents the fraction of habitable planets that actually develop life. Here too, we have no real clue what this number might be because we have yet to actually find life anywhere other than Earth. However, there's a lot of activity on this front. Researchers on the origins of life on Earth have concluded that basic single-cell life on Earth appeared almost as soon as the planet was formed and cooled. Evidence from Mars has shown more water and other factors necessary for life than we originally thought. Future missions to Mars, as well as some to the moons of Jupiter, might determine if life, or at least the building blocks of life, were able to form outside of the Earth. Drake initially thought that all planets in the habitable zone would develop life, but as of right now, we have no clue if that's true or not. It probably isn't 100%, but it probably isn't 0. The fifth variable is F sub I, which is the fraction of planets with life that develop intelligent life. And here we really don't have a clue. If we haven't even found single-cell life outside of Earth, we really can't even make a good estimate on how likely intelligence is to arise. There are a host of other problems with this. What is intelligence? Would dolphins on another planet be considered intelligent? How about a dog? The estimates for this variable vary widely. Some people think it might be close to 1, but others think it might be close to 0. One hypothesis is called the rare Earth hypothesis. This contends that simple cellular life might in fact be very common throughout the universe, but intelligent life, like humans, might be extremely rare. Life doesn't inexorably evolve to create intelligent life. The odds of an intelligent species evolving could be billions to 1. Drake assumed that this was near 100%. The sixth variable is F sub C, which is the percentage of intelligent civilizations that develop the ability to communicate through space. Basically, have they developed radio? Again, we have no clue what this might be. Could an intelligent species plateau at some Stone Age level of technology? Or maybe even a level like ancient Rome? Or maybe the level of technology required is something that we haven't figured out yet, and it isn't electromagnetic radiation at all. It could be that we're the ones in the equivalent of the Stone Age by galactic standards. The final variable is L, which is the lifetime of the civilization. Even if a species were to evolve to become intelligent, and they were to develop sufficient technology, there might only be a finite period of time where they're able to broadcast. They could be destroyed by a war, environmental collapse, get hit by a meteor, or maybe their star explodes. Again, this is a huge unknown, and estimates are all over the place. Estimates range for a few hundred years to infinity. So if you take all 7 variables and make some best guess estimates for each, what do you get? Well, pretty much anything you want. Estimates have ranged from Earth being the only intelligent technical civilization in the galaxy to there being millions of technical species. You might be thinking that this is all pretty useless if we can't even guesstimate an answer. However, it was really designed to be a way of thinking about the problem and starting a discussion, not necessarily an attempt to find a solid answer. One of the major criticisms of those who use the equation to argue that there are many advanced civilizations is, where is everyone? This is known as the Fermi paradox, and it'll be the subject of a future episode. The Drake equation was the first step towards trying to get beyond science fiction and trying to really understand if we are in fact alone in our galaxy. Over time, as we learn more, we'll have a better idea of the values of the variables in the equation and how likely it is that there are other intelligent civilizations. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Keever. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.